Hello ladies and gentlemen, my presentation is about building valid career ontologies with B-CPN. This work will be presented as part of the International Conference on Smart Applications and Data Analysis 2020. During this presentation we follow the following plan. I will start with an introduction. Then I will present the preliminaries, namely graphs, Petri nets and the B method. In addition, a formal definition of B-CPNs is provided. Moreover, we show in a practical way how such an approach can help us build and control a human resource career ontology. At the end we will present a conclusion with future work. Current human resource landscape is characterized by heterogeneous processes, human expertise, digital transformation, custom services, variety of missions and multiple data systems. In addition, we can learn the following challenges. Need for systems able to reconcile the heterogeneous human resource expertise and processes. Tracking and making sense of data on employees, candidates, skills, trainings. In order to meet these challenges, ontologies can be used here to model career evolution processes, and in the meantime, facilitate the capturing and exchanging of human resource data, such as skills, qualifications, hierarchy level and years of experience required to reach a specific occupation. An ontology is generally intended to act as a standard forming a set of controlled vocabularies and concepts. Overall, these ontologies bring opportunity to human resource teams have control on algorithms and data they use, paving the way to create resilient career planning models, increase productivity, and deliver effective guidance to employees and candidates. The major question in our work is, what is challenging in building valid ontologies? One approach is to use mathematical formal design and verification. With the recent advance in technology, mostly over the past decades, came actually the first use of mathematical tools to produce safe-by-design automation. Broadly in mathematics graph theory, a graph is a structure amounting to a set of data, organized as nodes, relationships, and properties. Data stored on the nodes or relationships. A Petri net is itself a graph containing two types of nodes. First, the places, graphically represented by circles, which can contain tokens, and second, the transitions represented by bars or boxes. Places and transitions connect to each other via directed arcs. These arcs can only link a place to a transition or a transition to a place. Moreover, another formal method is used in our work like B method. It is a formal method enables mathematical specification and rigorous representation and validation of functional properties when designing a given system. The B method has an end-to-end coverage of the development life cycle, from specification to implementation. Automatic or manual mathematical proof is accordingly possible to demonstrate whether invariant properties consistently hold when the system is operated. The strengths of B method are reliability of implementation, 5 and 5 against standards and requirements. Covers the whole system development life cycle, including code generation. Model checking and automated proof tools. For example Atelier B and Prob. But the weaknesses of this formal method require specific computer engineering and mathematical capabilities we discuss in this work, through a use case addressing the design of a career planning ontology that meets a set of human resource rules, how such a subclass of CPNs integrating B method notations, allows the construction and validation of ontology. Precisely. Our present research explores how the combination of colored Petri nets and the B method, particularly for use during the building and validation of a career planning ontology, can contribute to creating automated ontology development frameworks, providing purpose-built solutions to reliably handle algorithms in new human resource processes. B-CPNs refer to a particular structure of CPNs which is associated to a B-method machine and allows the CPN model elements to be annotated with B-language expressions. Such a CPN is intended to support both mathematical modeling and proof of properties through B capabilities and tools. Let's consider an analytical model for human resource departments, built by the French startup Toub, which, for every given candidate, predicts the best fit target jobs and existing skill gaps to be considered, all based on the company's or the sector's job and skill galaxies. To make it simple, each galaxy is a directed graph where nodes represent a normalized job or skill, and each two nodes are bound by an arc if they correspond to two successive jobs or subsequent skills. Let's consider a hypothetical IT company where employees show some occupations as presented in this slide, with their associated normalization including a few errors highlighted in red. A programmer, for example, was normalized to program manager instead of software programmer, or a test analyst was normalized to control tester instead of software tester. This kind of errors typically leads to a job galaxy that encompasses a number of doubtful links between some jobs. Hierarchical weights represent the number of years of experience required to move from an occupation to another. The control solution we develop as part of this example is a B-CPN model that proves the job galaxy used for career planning verifies all company career development rules, which are specifying the requirements to move into a given role. In this case, one rule will relate to the number of years of experience required to step in the target roles, which we will all express in B language as predicates. We formalize the job galaxy into a B-CPN model, then implement the human resource rules into the model's B-abstract machine, add the invariant clause, and finally, run automated proof and model checking to determine which nodes or archers from the galaxy cause invariants to be violated. Let's consider the two following human resource career development rules. To formally control using B method, the human resource career development rules are formalized as mathematical predicates, with a clear view on the variables to be used. Here state employee. For example, the human resource property stating that occupations of policy and planning managers can only be accessed from other families if the employee has 7 years of experience and at least 2 separate experiences. To make sure all possible cases are covered with regards to years of experience, we iterate the verification process from different initial states, where the number of years of experience will vary, for example, from 0 to 30. This process can be automated using specific scripts. In this work, we realize that ontologies have great potential in capturing and integrating the key human resource expertise. Based on the combination of formal methods, namely, the B method and CPNs, we introduced B-CPNs as a CPN subclass and presented a preliminary approach to constructing and validating career ontology graphs with a B-CPN model. Finally, we look forward to exploring in future work, a reinforcement deep learning approach, based on the formal validation of ontology-derived invariants, using the opportunities offered by interfacing colored Petri nets and the B method. This research aims to consolidate an artificial intelligence to fit company specifications, making sure there isn't any bias built in and increasing people's confidence in artificial intelligence-driven human resource management. Thank you for your attention.